Just a few days ago, the Americans succeeded in making oxygen on Mars. What would this mean when it comes to colonizing other planets? Would this mean that life is now possible on Mars? And what about the Moon or less hospitable planets like Venus or Mercury? Watch this to find out. I'm your host, Michael J. Taifour.
A small device, the size of a toaster or a car battery, generated 5 grams of oxygen on Mars. Imagine what this means to humanity. Imagine if it allows a human astronaut to breathe on Mars. The implications of that on the future of colonizing other planets are phenomenal. Like a tree on Earth, a small device inhaled carbon dioxide and exhaled oxygen. In just 1 hour, it was capable of producing 10 grams of oxygen. Imagine if it was able to extract 10 times or 100 times that amount using oxygen generators that are 100 times or 1,000 times larger. Would this make living possible on Mars? An architectural firm has designed a Martian city it said it could launch by 2054 and complete by 2100. This is when the first humans could begin living there. They've called the imagined city Nua, after a mythological Chinese goddess. Around 250,000 people could live there. But rather than buildings spread out across the planet's surface, the city has been designed vertically with buildings and structures built inside the rocks. This is to protect it from radiation and meteorites while giving it access to sunlight. Its designers imagined that people could live and work in macro buildings, constructed by tunneling and linked together via three-dimensional tunnel networks. At its highest point will be a vast plain, where manufacturing, food production, and energy generation facilities are found. The main city will be built at the slope of one of the Martian cliffs where water can be made accessible. With its plans said ready to go, it's now just a matter of time before humans begin living on Mars, in 70 years to be exact. Oxygen would be produced by plants, food would be 90% plant-based, and energy would come from solar panels. But what would life be like on the red planet? And how would future generations get there? Mars is half the size of Earth. Every 2 years, there are a couple of weeks when the planet is closest to Earth. So, the trip there would only take 6 months. However, the red planet is far from friendly. Its atmospheric pressure is not suitable for humans and its radiation is lethal. How could life there be sustainable? Well, the more important question is, would life be sustainable on Earth by 2100? It is believed that by the turn of the century, climate change would have reached a tipping point here on Earth. Famine and disease would have ravaged humanity. A new life might only be possible on off-world colonies. But where? Besides the Moon, where NASA is building a future base, and Mars, where Elon Musk, the founder of SpaceX, is building a colony, some say Venus. But Venus is toxic, hot, and inhospitable. Mars is deadly too, although in the opposite direction. Just as Venus is extremely hot, Mars is icy cold. Venus has a thick, poisonous atmosphere, while Mars has a paper-thin one. However, the inhospitable region of Venus lies far below, somewhere near the surface. Surprisingly, temperatures about 30 miles above the surface are Earth-like. At this altitude, atmospheric pressure is also similar to Earth at sea level. A spaceship named Havoc, which is still in design, would allow 2 astronauts to live on or above Venus for an entire month. During its first phase, its builders would send robots to Venus clouds. Phases 2 through 4 would be comprised of human missions. Phase 5 will set up permanent human habitation in a Venus cloud city. After that, who knows what will happen? Future missions would probably target distant stars in our solar system and perhaps other galaxies far, far away. Besides Venus, there's Mercury. But the problem with it is that it is too hot on the one side and frigid on the other. It's also extremely hard to get there due to the Sun's gravity. And Jupiter's out, considering that we would fry in a bath of radiation. The other gas planets aren't hospitable either. According to the Planetary Habitability Laboratory at the University of Puerto Rico Arecibo, there are up to 60 potentially habitable worlds within our universe. It all depends on whether they are close enough to their star to be warm, and not too hot, or too cold, and that water could exist in a liquid state. Of the 4,375 known exoplanets, only 24 of them are potentially habitable, says NASA. What will life be like in 100 years? Will our civilization as we know it be wiped out before then? A new city will be blossoming 270 million kilometers away from Earth. And, if all goes to plan, future generations will arrive on the red planet in just 70 years. Just looking at Nuwa, you probably would want to live there. But, with tickets set to cost an estimated $300,000, it's clear whom the city of Nuwa is designed for. However, Elon Musk doesn't seem to be prepared to wait for another 70 years of exploration before the 2100 move-in date. He is already planning on sending humans to Mars by 2026. He plans to build 1,000 Starship rockets and launch 3 of them a day to send 1 million people to Mars well before 2030. Other world nations are racing towards that goal as well. The United Arab Emirates, a rich oil country in the Gulf Desert, has already sent a mission to Mars last February. Now, the Sheikhdom wants to establish an international human settlement on Mars by 2117. And it's not just the UAE that is thinking about living on Mars. China too is focusing on the red planet as a potential second home for humanity. At this very moment, there are a total of 11 robotic missions exploring Mars. As the second most habitable planet beyond Earth in the solar system, these missions are busy answering vital questions about Mars' past, foremost of which is whether or not it once supported life, or if it still does. These efforts are expected to lead to significant advancements in just a few years and culminate with crewed missions in the next decade. However, the long-term habitability of Mars would require some serious ecological engineering, known as terraforming. Perhaps one day Mars could live up to its nickname, the Earth's twin. And let's not overlook Earth's other neighbor, also known as Earth's sister planet, Venus. It has a lot going for it that might make it a better candidate for long-term human habitation. But what exactly can the Earth's sister planet offer that the Earth's twin cannot? Like Mars, Venus was once a vastly different place. It is believed that until recently, Venus was a warm and wet planet where oceans covered 80% of the surface. However, a runaway greenhouse effect caused severe climate change, leading to the hostile environment that we see there today. If the planet could be restored to its former self by reversing the greenhouse effect, then humanity would have a planet closer to Earth that is roughly equal in size, mass, and gravity. Let's do a quick comparison. Venus is the closest planet to Earth, ranging from a minimum distance of about 23.7 million miles to a maximum of around 62 million miles. Because of the nature of our orbits, Earth and Venus make their closest approach every 584 days. In contrast, the average distance between Earth and Mars is about 140 million miles. Our two planets make their closest approach every 26 months. So not only does Venus get closer to Earth than Mars, but it also makes its closest approach to us more often. This means that missions to Venus could launch more often and would take less time to get there. Then there's the matter of Venus gravity, which is the equivalent of 90% to what we experience here on Earth, compared to gravity on Mars, where it is roughly 38% of Earth's. This means that for potential settlers, the health-related risks associated with lower gravity would be much lower. However, Venus has a hellish face that we should recognize. Its atmosphere is permeated by clouds of sulfuric acid rain. These have been observed in Venus' upper atmosphere and may not condense closer to the surface. But spacecraft attempting to land on the surface must first penetrate this acidic shroud. Venus also has the slowest rotation period of any major planet, taking roughly 243 Earth days to rotate once on its axis. On top of that, Venus rotates in the opposite direction as the Sun, which is something astronomers have only ever observed with one other planet, Uranus. So, between its slow retrograde rotation and the fact that Venus takes close to 225 days to orbit the Sun, a single solar day on Venus lasts 116.75 days. This means that for an observer on the surface of Venus, it takes close to 4 months for the Sun to set and rise again. Venus is also isothermal, which means that it experiences virtually no variation in temperature. This is due to its dense atmosphere, but also its slow rotation and its low axial tilt, which essentially means that Venus doesn't experience seasons or anything we might consider a day-night cycle. If this is beginning to sound to you like Dante's Inferno, then you're right. But with few retouches here and there, scientists believe they could turn it into a tropical island paradise. In other words, Venus could be terraformed into an ocean planet with mild temperatures and endless beachfront property. The first one to suggest this was Carl Sagan in 1961 in a paper titled The Planet Venus. Over time, humans could introduce terrestrial organisms like plants, trees, bacteria, and aquatic species to Venus. With some modifications, this could lead to an explosion of life and the development of a tropical planet, with biodiverse jungles on larger landmasses and more coastline than you can ever imagine. Unfortunately, it would take a massive effort to transform Venus. For it to be terraformed to become what it once was, the commitment would be nothing short of colossal. This leaves us with the second best option, Mars. Elon Musk once summarized the challenge of creating a self-sustaining city on Mars using a real estate metaphor. In a 2012 interview with CBS This Morning, he said that, "You need to live in a dome initially, but over time you could terraform Mars to look like Earth and eventually walk around outside without anything on." So, it's a fixer-upper of a planet. If we were to view Mars as a prospect, fixer-upper would certainly be an apt description. If we want to live there someday in large numbers, we are likely to have to alter the environment. Hence, Mars is move-in ready, while Venus is a tear-down and rebuild. Therefore, cities with a few hundred inhabitants could be established on Mars soon. Over time, these settlers could gradually transform the Martian environment, making it suitable for more and more inhabitants. By the time it becomes fully settled, there will be solutions to all its hazards. Does this mean that we are ditching Earth? The answer is yes. We're giving up on Earth, having mined it for its natural resources and primed the climate for ruin. It's true, our industrial revolution has taken a huge toll on Earth's environment and biodiversity. We've witnessed wide-scale extinction at our own hands. As a civilization, we are not taking the responsibility to fix that. But consider Earth in 50,000 years, when the next glacial period will ravish the land, creating catastrophic cooling, range contractions, and extinctions. It will last for 90,000 years. Humanity itself may not survive, yet the third rock from the sun will still be here doing its thing long after we're gone. Earth will be around for another 7.5 billion years before being absorbed by the sun. Yet, we must hedge our bets by establishing independent colonies on other moons and planets. We'll distribute the eggs of humanity across multiple baskets so that a catastrophic basket loss won't commit our species to extinction. If the dinosaurs had possessed this ability, they'd have gone multi-planetary too. It's a matter of survival of the fittest.
Back in the 1960s, Star Trek referred to terraforming or earth-shaping other worlds. Today, this science fiction is becoming a reality.